Hello students, this is the Unit 5 Lesson 5 video on triangle inequality. The topic that we're going to be going over today is the triangle inequality, which says, in other words, that the largest side of a triangle is going to be smaller than the sum of the other two sides, the two shorter sides. It's a corollary of this very basic geometric concept, which says the shortest distance between 2 points is a straight line. That should make perfect sense to you. The shortest distance between any 2 points from here to here, for example, is going to be a straight line. It would be longer to go from here to here, from here to here, from here to here, and so on. You might be wondering why I have a picture of a bunch of these analog clocks on this slide, but don't worry, you're going to find out soon enough. The learning target for today is you're going to be able to justify the triangle inequality, so in other words, explain it and give reasons for it. And then you're going to apply that concept to identify unknowns, possibly self or variables, and also create intervals of possible values. So the objective for today is to do all of those things. And you see the analog clocks again coming up here, and hopefully the do now explains why we see them. The minute hand, the long hand, so if I'm looking at the analog clock, this long hand here is 4 inches long, and the hours hand, which is the slightly shorter one, is 3 inches long. So now the question is, what is the farthest apart that the ends of these two hands can be? Now what I'm talking about here is the ends of the two hands. Like for example, this end here and this end here. So how far apart could they be? Of course, you could measure it like this by saying, well, I'm going to go from here to here. I'm going to go from here to here. I'm going to go from here to here. All those kinds of ideas. So think about it for a couple of minutes. What's the farthest apart that these ends of the two hands can be? And also, what's the closest that the ends of these two hands can be? Think about it for a couple of minutes, then pause the video, try it out, and then come back to see if you got it right. Let's take away these dotted lines. All right, so I've identified the two clocks that they're talking about. One of the clocks is the answer to letter A. What is the farthest apart that the ends of these two hands can be? Well, I highlighted it in blue. And it says that the two hands could be pointed away from each other. It should make sense to you that if this hand is 4 inches long and this hand is 3 inches long, if they're pointed exactly away from each other, the two hands are going to be 7 inches apart. And then similarly, if the two hands are pointing in the same direction, they're sort of overlapping each other. The hours hand is going to be over the minutes hand, but they're still pointing in the same direction. And in that case, it's going to be 1 inch apart, which should make sense to you because we took 4, which is that longer hand, and we subtracted 3 to get 1. These two examples, the two examples that I've highlighted, show the two hands that are both lying in the same straight line. In other words, they're both lying on that vertical straight up and down line. In all of the other examples, you have the two hands of the clock that are pointing in different directions. And what you could do for all of these other examples is to create triangles. And in all of these triangles, that side, that third side that we drew in here, let's actually color code those sides so you can see all of those red sides that I drew in here. All of these sides are going to connect the two ends of these hands of the clock. But notice that based on what we identified before, if we're going to try to make a triangle out of this thing, the smallest or the lower limit is going to be 1 inch. And the upper limit is going to be 7 inches. In other words, if I want to make a triangle, I'm going to have to connect these two hands using a line that is smaller than 7 inches long and larger than 1 inch long. Otherwise, it's just going to be a straight line, not a triangle. All right, so in order to make a triangle, it's got to be larger than 1 inch long and smaller than 7 inches long, the connection between the two hands. That is an example of what's called the triangle inequality theorem. According to the triangle inequality theorem, the sum of the lengths of any two sides of a triangle must be greater than the third side. In general, the way we write it is the sum of the two shorter sides is going to be bigger than the third side. In other words, I'm looking at 3, 5, and 7 here. I know that if I take the two smaller sides and add them together, that sum, which in this case is 8, has to be bigger than the longest side, which it is, 7. If I added these two numbers up and I got a number that was smaller than this side, then those lengths would not make a triangle. Here's an example. I know that this side is 5 and this side is 3. So if I took these two sides and dragged them out here a little bit, I would not be able to make a triangle if I went like this. I swiveled this around so it was like this. So I wouldn't be able to make a triangle that is 5 plus 3, 8 with its other side. It just wouldn't work. It's not a triangle, it's a straight line anymore. So 5 plus 3 is equal to 8, which means if I'm trying to make a triangle, that third side has to be something smaller than 8. That's the general idea. Anyway, let's take a look at the model problem number 1. In triangle ABC, which is not drawn, it says that AB is equal to 5 meters, and it also tells us that BC is equal to 3 meters. So we're supposed to write an inequality that represents all possible values for the lengths of AC in meters. So let's try to draw any old triangle ABC. And similarly, let's try to label all of the sides of this with what is given to us. And you'll notice that these sides don't look exactly proportional. This triangle is not drawn to scale. I just drew any old triangle ABC. But keep in mind, that's not really going to matter because once we start using our triangle inequality, we'll be able to figure it out algebraically. We don't have to worry about what the diagram exactly looks like. So now we're supposed to write an inequality that represents all possible values for the length of AC in meters. So now we're going to have two different scenarios. The first scenario that I'm thinking about is, well, what if AC happens to be the longest side? Well, if AC is the longest side, that means that this side and this side are the two shorter sides, so I should add those together, and the longest side is going to be smaller than the sum of these two. That's what it says. The sum of the lengths of any two sides of a triangle must be greater than the third side. So I add 5 and 3 together, and that's going to be less than, that's going to be greater than that longest side. So I'll say that AB plus BC is going to have to be greater than AC, based on the triangle inequality. So I substitute in 5 and 3, and I find that 8 is greater than AC, or if I want to read it the other way, I can say AC has to be smaller than 8. So I still don't know what AC is, but I do know it has to be smaller than 8. Now I'm going to make the opposite assumption. What if AC is the shortest side? Well, if AC is the shortest side, then I would assume that both of these sides are longer than it. So in other words, if AC is the shortest side, then the largest side is going to be AB, which means I'm going to set up my triangle inequality with AB on the right-hand side, because AB, in our new case here, is going to be the longest side. So now that I've written out my triangle inequality, assuming that AC is going to be the shortest side, which means AB is going to be the longest side, I'm just going to fill this in and then see what it gives me. All right, I know BC is 3, I know AB is 5, so I solve this inequality by subtracting 3 from both sides. I get AC is greater than 2. So now I have two constraints. Constraints are like limits or like rules that a certain variable has to follow. I don't know the value of AC. However, I know that AC has to be smaller than 8 and AC has to be bigger than 2. The question asks us to write an inequality that represents all the possible values of AC. So now we have enough information to write this inequality. I know that AC has to be a number that's in between 8 and 2. So let's write a compound inequality just like you learned how to do in algebra. All right, since I know that 8 has to be less than, AC has to be less than 8, and I also know that AC has to be greater than 2, I could say AC is a number between 2 and 8. This is what it's asking for, write an inequality that represents all possible values for the length of AC in meters. So I guess specifically all of these should be in meters. I'll have to go back and check. Oh, looks like it just fixed itself. Look at that. All right. I'm moving on to model problem number 2. Model problem number 2 deals with this tool, which is called a compass. We usually use compasses in geometry. Unfortunately, currently we're not allowed to be in school together. However, a compass, as you may or may not know, is a tool in geometry that allows you to draw perfect circles and parts of circles called arcs. So the arms of this compass are both 9 centimeters. So I can label those as being 9 centimeters long from here to here. That's 9 centimeters. And as well as this side, that is also 9 centimeters. Great. So it asks which of these circles can't be drawn by the compass. So let's try to figure out how I would turn this scenario into something that's related to the triangle inequality that we just talked about. Pause the video, think about it for a little while, and then come back to see how to do it correctly. All right, in order to help you visualize this, I created something that sort of looks like a compass, and you can see the 9 centimeters on both sides here. These are the two legs or arms of the compass, whichever is your pleasure. And you can see that it's drawing a circle sort of on this flat surface. This is more like a three-dimensional picture here. Now, what I want you to realize is that the distance between these two legs or arms of the compass, that's going to represent the diameter of the circle. Because, of course, diameter is the distance from one edge to the other edge of a circle that passes through the center of the circle. And another word that they use in this problem is the radius, and you know that the radius is half of that distance. Those are concepts that you learned about back when you learned about shapes in the earlier grades. Okay, so now what we can do is we could sort of write down sets of sides of this triangle that we're drawing, 9, 9, and something, and then we can determine which of those sets of sides are going to make a triangle and which ones are not. For example, in this one, it says diameter of 10 centimeters. So if it's got a diameter of 10 centimeters, that distance is from here to here. That means the triangle would be made up of 3 sides, a 9, and a 10. So the set of sides here would be 9, 9, and 10. Now if the diameter were 20 centimeters, from here to here was 20 centimeters, that would mean that the 3 sides would be 9, 9, and 20. For numbers 3 and 4, it talks about the radius, but that's okay, we could figure this out. If the radius is 6 centimeters, this blue part, then the rest of it would be 6 plus 6, and so that means the diameter would be 12 centimeters. And last but not least, if I know that the radius is 1 centimeter, then the diameter, you guessed it, is twice that. That's 2 centimeters. So my last set of sides would be 9, 9, and 2. I'm going to write it in order from least to greatest because that's the easiest way that I can think of to apply the triangle inequality. Okay, remember how the triangle inequality works. The idea is we're going to add together the 2 smaller sides, like in this case the 5 and the 3, and see if that 7 is bigger or smaller than the sum. It says the sum of the lengths of any 2 sides, the shorter sides of a triangle, must be greater than the third side, the longer side. So as long as the 2 smaller sides add together to be a number that's bigger than the third side, we're good to go. So let's add these together and see whether they work. All right, in the first one, we added 9 and 9, that's 18, and 18 is greater than 10. That's good. We want the sum of the 2 smaller sides to be bigger than the third side. So this proves to us that the first choice is a possible measurement of the 3 sides of a triangle. Well, remember, we're looking for which of the circles can't be drawn. So this one can be drawn, so we'll cross it off. Let's try the next one. So we add 9 and 9 together. 9 and 9 is 18, but it turns out that 18 is not greater than 20. This inequality does not follow the triangle inequality rule. It's not an accurate inequality. So at present, we believe that this is the correct answer. So far, this is the only correct answer we found. This one cannot be drawn by the compass. And it makes sense because if the compass's arms are only 9 and 9 centimeters respectively, how are they going to make a circle that's 20 centimeters? That's just too big. Even if the 2 arms were spread as far apart as they could be, they wouldn't make a 20 centimeter circle. Trying out the third set, 9, 9, and 12. I know 9 plus 9 is 18, and 18 is greater than 12, so this one does work. Just making sure that all the other ones are copacetic here. And then last but not least, we have to check 2 and 9. 2 plus 9 is 11. And that third side, which is also 9, is smaller than 11. So this one works as well. So that is not the one that can't be drawn. So long story short, we're looking for the one that doesn't satisfy the triangle inequality, and it was only one of them, choice 2. I would ask you to go on to the check for understanding, which are examples of both of those types of problems. However, you don't have to do them right now. You're going to do them in class. All right, this was the video on the triangle inequality that says that when you add the 2 smaller sides of a triangle, it should be larger than the third side of the triangle. All right, folks, good luck studying.